Hi everyone, and welcome to the Chapter 3 lecture on central tendency. Central tendency is a statistical measure used to determine a single score that defines the center of a distribution. We have three measures of central tendency: mean, median, and mode, and we'll talk about each of these individually. Mean is a sum of the scores divided by the number of scores available. For instance, say we have 8 scores: 1, 5, 10, 7, 8, 3, 6, and 8. We would add these scores together, which equals 48. And again, there are 8 scores total, so we divide 48 by 8 and we get 6. You can think of the mean really as the balancing point or the center of a distribution of scores. If we take a look at these normal distributions, which we learned about in the last chapter, we have a wide range of scores, but the average is really that center point of the distribution, at least when the distribution is normal. In statistics, we calculate means for different groups of people. And if you remember from chapter 1, we have populations, which refer to all people in a group, and samples, which refer to a subset of that group. We calculate means of populations and samples the same way, but we do use different notations. For the population mean, we have mu, which is the symbol for the population mean, equals the sum of scores divided by the number of scores available. Likewise, we have mu, the sample mean, equals the sum of scores divided by the number of scores available. The notation you use is important because it reflects which scores you're using. Base your notation on what the problem tells you. Here's an example problem for you to try. A psychologist is interested in depression ratings among college students at a large university. Out of 18,000 students, 20 are chosen to participate in the study and are provided with a depression symptom survey. Using the proper notation, what is the average of the scores below? Pause to solve. The answer will show in 5 seconds. Okay, so we solved this problem by using the sample mean notation because only 20 out of the 18,000 students participated. We don't have the full population. We add up the numbers, which equals 355, and we divide that by the number of people we have, which again is 20. And this gives us a mean of 17.75. But say you have two different means. You have depression scores from two different universities and you want to combine them. To do so, you would use the weighted mean. In direct terms, the weighted mean is the combined sum of both groups divided by the combined n. In statistical notation, this is shown as a sum of x for group 1 plus group 2 divided by the n of group 1 plus the n of group 2. However, we don't always have raw scores for both groups. Maybe we ask two universities to provide data on their students, and they send us back means and ends, but not the listed scores of both groups. In that case, we would take the means and multiply them by their ends. And this is important because it weights the mean. If one group had 20 students and the other had 5, you wouldn't just average the two means because the bigger group would count more. So that's why the weights, the ends matter. Here's a weighted mean practice problem. We have two universities with means and ends. Feel free to pause here if you would like to solve it on your own. Okay, so taking that equation, our M1 and N1 are the numbers from University 1, and our M2 and N2 are the numbers from University 2. We multiply the numbers, remember to solve anything in parentheses first, and then add them together, and we add the sample sizes in the denominator. This leaves us with 9,135 plus 13,984 divided by 257. Simplifying this, that is 2,119 divided by 257, which leaves us with 89.96 as our weighted mean for the two samples. Moving into the median refers to the score that divides a distribution in half so that 50% of the scores are above and 50% are below. You can think of this as the middle point of the distribution. For instance, if we have the numbers 2, 4, 6, 8, and 10, we can cross off the endpoints and then do that again until we reach that middle number, which in this case is 6. And it's important to remember to always put these numbers in numerical order. You can imagine that if they were in a random order, the middle number might not be the correct one. If you have an odd number of scores, the median is relatively easy to find because it's always that middle number. We can do the same thing here where we put the numbers in order and then mark off the end numbers until we reach the middle, which in this case is 7. However, say you don't want to solve by marking off each number individually because it takes up space, or there are so many numbers that this would be time-consuming to do. You can also solve by adding 1 to your n and dividing by 2 to find the term. In this case, there are 15 scores. If you add 1 to 15 and divide by 2, you get 8. So drawing your eye up to the list of numbers, we're just going to count left to right until we reach that 8th term, which again is 7. So our median is 7. Finding the median when there's an even number of scores is a little different. If you were to cross off the end numbers, we would be left with 2 numbers, 7 and 8. When this happens, you take the average of the 2 numbers, add 7 and 8, and then divide by 2. In this example, the median is then 7.5. There's an alternative way to solve when you have an even number of scores as well. The equation looks a little intense, but it's not nearly as bad as it looks. You take the n, again the number of scores you have, and divide it by 2, and then repeat that, adding 1 to it. This allows you to find those 2 middle terms. Then you just divide by 2. So let's solve using that same example. We have an n of 10, so 10 divided by 2 is 5, and then n divided by 2 plus 1 is 6. So we are looking for the 5th and 6th term. Drawing your eye again to the list of numbers at the top of the screen, we'll count left to right. The 5th term is 7, and the 6th term is 8. So just like before, 7 plus 8 divided by 2 is 7.5. Here are 2 median practice problems for you, one with odd numbers and one with even. Feel free to solve this however you'd like, but make sure to first put the numbers into numerical order. Pause to solve, the answer will be shown in 5 seconds. Here are the answers to both of those problems. If you run into any issues with this, go back and see if you can identify which step you missed. And if you still need assistance, please contact me so we can work through them together. Mode is simply the score or category with the greatest frequency. I like to remember it with the saying, mode is the most. For instance, looking at these scores, 8 shows up 5 times, more than any other number. So the mode is 8. I don't have any practice problems for this because students can typically solve for the mode on their own. The mean is the most used measure of central tendency, but it can be skewed by extreme scores. There's a famous example of this called the feudal village example. In this fictional village, there are 50 families that make only $100 per year. That means that in total, 50 families accumulate only $5,000 per year. However, there is one very wealthy family that makes $100,000 per year. That means that for 51 families, the total amount is $105,000 per year. If you take the mean of that, that would suggest that each person on average makes $2,059 per year, which is way above what most people actually make and is not representative of the villagers. However, both the median and the mode is $100, which is more accurate. The measure of central tendency you use depends on the type of data you have as well as your distribution. The median is a good choice if you have ordinal data, which, if you remember from Chapter 1, is that data with an ordered sequence, such as small, medium, and large. And it's also a good choice for skewed data. You can see from this graph that the median is the midpoint regardless of skew direction. Mode is the best when you're using nominal data, which again is just categorizing data such as color. Or when you have a discrete variable, say you're measuring dice rolls, there's only a limited number of outcomes, right? Using the mode, you could tally up how many times those outcomes happen. If the distribution is normal, the mean, median, and mode are all at the same point in the distribution. We would call this a unimodal, meaning one mode distribution. However, sometimes you might come across a bimodal distribution, such as the middle image where there are two peaks, and the mean and median sit in the center. Or you might come across a distribution in which all the scores are the same, so there's no mode at all. This simply highlights the importance of examining your distribution once you collect your data, because it may influence your choice in measures of central tendency and therefore more complex analyses down the line. And that is all I have for you. Please let me know if you have any questions.